All right, so we're going to find the explicit formula for the nth term of the given sequence. So remember, the formula for the arithmetic sequence is going to be your first term, so a, or some people like saying a sub 1, plus n minus 1 times your common difference. So the two pieces of information that you need to find are always your first term and your common difference. And then you just plug it into the formula. So in this instance, my first term is negative 30. And then my common difference, it's going down by 10 every single time. So my d is going to be negative 10. So then I'm going to take those two pieces of information and I'm going to plug it in. So a sub n equals negative 30 plus n minus 1 times my common difference. Looking at another one. We have our a sub 1, so that's our first term. Our common difference, so it looks like it's going down by 30 every single time. So that's going to be negative 30. So my formula is going to be my first term plus n minus 1 times my common difference. And so looking at this one, my first term is going to be 9. My common difference, it's going up 5 every single time. And so it's going to be 9 plus n minus 1 times my common difference. Finding the distance and the midpoint between 2 points. So remember the distance formula. So plug in the values in. This is your x1, this is your x2, this is your y1, this is your y2. So x2 minus x1 squared plus y2 minus y1 squared. So that's negative 4 squared plus, that's going to be 12 squared, so that's going to be 144. So that's 16 plus 144, which is going to be the square root of 160, and then I can break that down into the square root of 16, the square root of 10, and so I'm going to get 4 root 10. The midpoint, you add the ends, divide by 2. So add the x values divided by 2. So 2 over 2 is 1. Negative 8 over 2 is negative 4. And so that's my midpoint. There's my distance. There's my midpoint. Okay, so the parent graph of a square root function looks like that. But there's a reflection over the x. So then it's going to reflect downward. And then there's a horizontal shift of 3 and a vertical shift of 2. So horizontal shift of 3 and a vertical shift of 2. And then I draw that shape. And so my domain is going to be from 3 to infinity. My range is going to be from negative infinity, and it's going to stop here at 2. Now, as a reminder, this is a cubic function, and so that's the parent graph of a cubic function. This is an absolute value function. This is the parent graph of an absolute value function. It says determine if the sequence is arithmetic or geometric. It's going up by 3 every single time, so therefore it's arithmetic. This one looks like it's times 4, I don't know, plus 3, and then plus, okay, no. Oh, it's 1 squared, 2 squared, 3 squared. Okay, that's neither. There's a pattern there, but it's not an arithmetic or geometric pattern. And this one is times 5 every single time, so therefore it's geometric.